In this chapter, we're going to look at numbers, strings, and dates. And in this video in particular, we are going to look at the number object. So there's a number object that's built into JavaScript. It has some static properties and it has some methods that we can use. So let's take a look at some of those to start out with. We're going to start out with the static properties in the number object. So these are a way you can think of it as built-in values that can be used like a constant that's built into the number class. So number.maxValue, that's the largest number that JavaScript can be represented. Whatever that number is, and it's a huge, huge number. I can't even remember what it is anymore. I think it's like 1798 followed by 305 zeros is the largest number that JavaScript can represent. It's a very big number. Number.minValue is the minimum value that JavaScript can use. There's also a maximum safe integer. It's the largest integer that can be stored accurately by JavaScript, and the minimum safe integer is likewise the smallest integer that can be stored accurately. Here come the two that get people: positive infinity and negative infinity. So what is positive infinity? Any number in JavaScript that's bigger than the max value is considered to be positive infinity. We can't display that number, so if a number's at the max value and it goes one bigger, it becomes positive infinity. We can also just use the keyword infinity instead of saying number.positive_infinity. We can just say infinity. So for example, if I wanted to set x equal to infinity, I could just say x equals infinity as a shortcut of saying x equals number.positive_infinity. Okay, so negative infinity is that minimum value, anything smaller than the minimum value or more negative than the minimum safe value. We also have number epsilon. That's the difference between 1 and number.minimum_value. Okay, so if we think of minimum value as the smallest decimal number we can hold, it's 0.00000000 something. Whatever that is, if you subtract it from 1, that's what epsilon is. And NaN represents value, a value that isn't a number. So I could set x equals to number.nan or NaN, and basically I'm saying, hey, this variable is not set to a number. Instance methods of the number object. Once we have a number object created, we can call toFixed, and inside the parentheses I could say, for example, 2, and it would round it to 2 decimal places. There's also a toString, so we can take any number or any number variable and call .toString to convert it to a string, but also you can stick a base in here. So if I put 16 in here, it would convert my traditional number to something in hexadecimal. That could be quite handy if you're doing some kind of networking program. So let's look at some examples of that. We have a constant subtotal equals $19.99. The rate is 0.075. We take the subtotal and multiply it times the rate, and we're going to get 1.499925 for our tax. And if we say tax.toFixed and put 2 in there, it's going to round our tax to $1.50. Okay. Implicit use of the toString method. So we don't always have to actually take like tax.toString if we want to use it, or in this case age.toString. Anytime we're doing concatenation, your age is, and then we put plus as a concatenation sign, and we put age out here, it's automatically going to take age, which is a number, and run its toString. So that's why it's called implicit, because we're not explicitly saying age.toString here. When we just say age, it automatically runs the toString method, which is built into that number object. static methods of a number object. We have number is NaN, and before you get confused, remember there's an is NaN that is also a global. So this is not a number that is built in to the number object. And they work differently, and that can be very confusing to people. And those same differences also apply to number dot is finite. There is a global is finite function that we can use that's not part of the number object. And it also works differently, and we'll see that in some upcoming slide. We can say number dot is integer, and it will and whatever value we put in here will determine whether it's an integer or not. And also is safe integer. If we stick a number in here, it'll tell us if it's a safe integer. So let's look at some examples. Example 1, is NaN versus number dot is NaN. So is NaN is the global function, is not a number that we've used a lot so far in this course. We've seen it on occasion. And then we have number dot is NaN. What is the difference? Well, the difference is the global object. When JavaScript was first written, it said they thought it had this great idea that will let Java, no matter what type a person is using, if the thing they're trying to do needs a different type, we'll do all these automatic conversions, and that'll help them. And in fact, it created bugs that are really hard to find. So the global is NaN is one of those things. If I pass something into here, it will try to convert whatever I pass in. For instance, this string of 4, the global version will try to convert that to a number and then decide whether it's not a number or not. Okay, so the global version looks at this and says true. It looks at this array of numbers or this list of numbers and says, is it not a number? And it'll say true, it's not a number. Okay. And is NaN on not a number will also display true. Now let's compare that to number dot is NaN, which is the same named function, except this is the function that is part of the number object, and it does not try to convert them. So is NaN with a string is going to display false. Is NaN with this array is going to display false, and is NaN with NaN will display true. So you can see they get different results. So you need to understand which one you're using, whether you're using the global is NaN or the number dot is NaN. Number dot is NaN looks to see if it's a number first. It does not try to convert it to a number if it's not a number. And then it tests to see if it's a valid number. Okay, is finite is kind of the same way. There is a global is finite method that does not try to do that tries to convert everything, but number dot is finite does not try to convert anything. It displays false for anything divided by 0, but for 200 it will display true. This is a finite number. These two, JavaScript would consider them infinite. Using the is integer and safe integer methods. Okay. So I have max safe integer. Remember we said that's a built-in static field. Number dot max safe integer. That's the biggest integer I can use safely in JavaScript, and I just added 1 to it. Uh-oh, that could be a problem, right? So I take this number that I just added 1 to, and I can run it through number dot is integer too big, and it will say, yeah, that's an integer. Is it a safe integer? It will say false because it's 1 bigger than what would actually be safe. And then if I take too big and subtract 1, and then see if it's a safe integer, now it would be safe because I subtracted the one that I added and it displays true. All right, in our next video, I believe we'll be looking at strings.